Right, thank you everyone for joining. This is our last session before lunch, and we have a recorded presentation from Susan Lawson. As you are probably aware, if you've been in DB2 for long enough, Susan Lawson is a superstar in DB2 history. She has contributed to practically every DBA's career that I know of in one way or another. And she has kindly recorded this message, this presentation for DB2 12 and 13 for ZOS database design for application performance. Unfortunately, she is currently in flight somewhere above the planet. And if you do have any questions, then please make a note of her email address, susan_lawson@ylassoc.com. And she said that she would endeavor to answer any of your questions. So once again, thank you very much. And I will share my screen. And it's this one.
Hello, this is DB2 12 plus and 13 for ZOS database application performance, features, and usage. My name is Susan Lawson, and I will be presenting for you on various aspects of DB2 12 and all the various function levels and APARs that have come out since the beginning, well, since 2016 when 12 was announced, and as well as we'll look at features in DB2 13, which was announced in May of 2022, and it since 2 has had a function level, and we'll look at any features and of these APARs and function levels that apply to our day-to-day work in database design, application design, performance, and we'll take a look at how to use some of these features in our environments. And when I mention using these features, using features that come out in different levels of DB2 releases, if we're not actually exploiting and using these features, we don't get the benefits from what these releases have to offer and what these features have to offer. And the only way we're going to really achieve high performance and availability and scalability in our environments and with our applications is to implement these features. And that's the purpose of this presentation, to take a look at those things, evaluate them, see if they apply to us, if we can use them, and how we're going to use them. So starting with the database features. As you know, relative page numbering came out in version 12 in the initial release. That allows us to have a new page numbering mechanism instead of absolute page numbers. We have relative page numbers, which allow us to remove some of the restrictions we had before with the absolute page numbers. It restricted us on the number of partitions we could actually have because it was, tied to our page size. And so the absolute, though, is remaining as the default for creation of our table spaces in version 12. But in version 13, you'll see that there is a new default setting for this, and it's through the zparm page set page num. And that allows us to have relative page numbering used by default for our partition by range table spaces that are created. One thing to keep in mind is that this range relative page number does require you to have extended addressable, extended function data sets available. And then that's also, you can see here in the settings for your installation settings on this panel that a relative is going to be now the default for your page sets. There's also improvements for RPN table spaces in terms of inserts. There was an issue with inserts in a data sharing environment with RPN table spaces because of the number of data page p-locks that needed to be taken. This is particularly frustrating with row level locking because there was a lot of unique hash values that had to be generated because Db2 only uses p-locks on pages, not rows. So every time you needed a row lock, it had to take a p-lock regardless of the number of rows per page that were being accessed, and that would have to generate a hash value for the X-lock on that p-lock. And that resulted in, of course, false contention as you're having to have more lock entries for these locks. And so there's some new internal algorithms that are going to allow some less chance of false contention happening because there'd be a more balanced distribution of hash values, and they won't have to take as many p-lock hash values. One of the big features of version 13 is the ability to migrate or convert from a partition by growth table space to a partition by range table space. And this is a big benefit to those wanting to utilize partition by range. And it was a problem in the past trying to do this conversion. It's a long process and it required an outage. And with this ability now, with this new alter partitioning to partition by clause, the conversion is immediate. You have to have the data sets already defined. It will become a pending reorg. You'll have to materialize this through a reorg. It is converted to a table space that is partition by range, but it's an RPN, of course, because that now is our new default, as we just discussed in Db2. And it does not affect any of the indexes, and is done during the, does not affect the indexes during this conversion. Also in version 13, through a recent APAR release last year, they relieved some restrictions on the changes that you can make during a conversion. You know, if you may want to be making changes to the buffer pools or seg sizes, or I'm sorry, not seg size, DS size, or altering a column or compression, you had to do those one at a time. If you had to do the conversion first and then the alter. You could not stack them and have them materialized by one single alter. So it would require two alters for those changes. In version 13 with the APAR, you can stack those changes. You can do the PGB to PBR conversion, as well as change something like the DS size during that and have it be all materialized in a single reorg execution. Max partitions got a new default in version 13. In version 12 and 504, the default was 256, regardless of what was specified. When the DS size would default to 4 gig, regardless of the page size, which could result in a problem because with a max partition table space, it's using absolute page numbering, and that could lead to a problem with the relationship between the page size and the number of partitions that you could have. That could result in an error if it went over 254 partitions. So with version 13, the max partitions has been changed to 254 by default, and with that, regardless of the max partition specified, the default size for the DS size is always going to be 4 gig to eliminate that problem. So max partitions 254 by default, and your DS size is always going to be 4 gig. Increased number of partitions, or open data sets, I should say. the reason we need more open data sets, of course, is because we're converting to these PBG table spaces, and they're going to require an increasingly number of open data sets and partitions. There's a number of reasons why we need more open data sets. We also are reaching limits sometimes where, we reach our DS max, things get closed, and then if they're frequently used, they get reopened, and that's causing performance problems. Well, now in version 13 with ZOS 2.5, there's been some more improvements in memory, and more control blocks have moved above the bar. And so that allows us to have more concurrent data sets open. Therefore, the limit has been increased from 200,000 to 400,000 for those number of open data sets. And this area of memory that has been relieved also allows to have more concurrent threads, as we'll discuss later. Improved data capture. Data capture, if you are altering data capture to allow for replication, you have to quiesce your static packages and cache dynamic statements, which is not an easy thing to do in a highly available environment. So in function level 500, Db2 13, data capture no longer waits for dependent DML to commit, and the operation can run successfully even when static or dynamic DML is currently running against the table. And so therefore no longer will you have to have this sort of outage when having these statements and packages quiesced to do the data capture alter. Longer names. This is probably more of a compatibility type of feature where Db2 can support longer names for columns. Previously, our column names were, of course, limited to 30 bytes. And in Db2 13, we'll be able to have larger column names. There'll be a ZParm there that helps support that, or that actually turns it on for us. And then allow for column names to be created longer than 30 bytes. And of course, it can be used anywhere. There is one limitation, though, that you need to be aware of. That is, SQLDA does not support the longer names. So any interface that gets its information from SQLDA will be only returning 30 bytes. And that includes spoofy, QMF, TEP1, declgen, and so forth. Non-deterministic column expressions for auditing. This is a really cool feature that came out in Db2 12 in 503, and it allows us to support column or auditing against our data in our table. And it tells us more than what temporal begin and end of our change tells us, because it's going to tell us who, how, and what type of change was made. And it's better to show an example here. So as you can see, we have these expressions that we can add to our table, and we can capture the current SQL ID. So we can find out the who. We can find out what operation was done against the table. So the data change operation was an insert, update, or delete. And then we can also capture the deleted row if we want now too, with these expressions. And so this was applied in, I think it was, I said 503, and this allows us to have this type of information collected, and it is done right in the table. It's a built-in function, and it's a lot cheaper than doing this through something like a trigger. Movement from a multi-table table space to a UTS. This was a bit of a hassle prior to function level 508, version 12, because it was a multi-step process to be able to do this, to be able to move from a multi-table table space. You had to move a table at a time to a UTS, and it required a lot of work. This feature is an alter table space with a move table option. It's some new DDL that we have that allows us to move our table from a multi-table tablespace to a PGB or PBG tablespace. It is done as a pending change that gets materialized by a reorg. Now there is more steps to it than I'm giving you. You can of course find them in the admin guide, and it identifies in this statement which table space you're going to move to, so you need to have that created. And the recommendation has been, if you are undecided about what size table space you need or want, the recommendation by IBM at this time was to start with a max part 1 partition by growth table space. Now, a lot of times moving from partition by growth to partition by range does not happen because you might go partition by growth because you don't have a good key limit number to do partition by range. And so that might limit your need or want to move to a partition by range table space. But there are so many more benefits to using a partition by range table space, as we'll discuss later. But one thing that came out in version 12 through, again, some APARs, is the ability to have a hidden row ID. Now you can use this hidden row ID as a key, and so that would allow you to move to a partition by range table space and have a key to support your range partitioning. Now some benefits you might see by this, because this is a random number, some people see that you might get better insert throughput and less lock contention on data and indexes because your inserts would be going all over the table space. But on the other hand, sometimes that can be a bit of a challenge too, because you don't have the ability to maintain clustering, you get bad sequential processing, less efficient write IOs, free space challenges, etc. So there are pros and cons, of course, to doing that, but I just wanted to let you know that that option is available. So, no longer do we, have an excuse to say, I don't want to go partition by range because I don't have a limit key. So this is one option if that is the case. So back to partition by growth. Partition by growth have had their challenges, and that's why it's been encouraged for people to use partition by range instead of partition by growth because of some of the challenges with the performance with these types of table spaces. So during the insert process, the partition by growth table space will try to insert into the next available partition, and if it's full, the target partition gets skipped over, and he tries another partition, another available partition, and it will search till the last partition is searched. It's going to try to insert this data, but if it can't get a lock on the partition also, it will not be able to do the insert. So if the partition's full, that's one problem. If it's going forward and it encounters locked partitions, that's another problem. But what happens is it doesn't retry that insert. Even though those locks are relatively short, it doesn't retry that insert, and it doesn't look back either. So it doesn't do a bidirectional partition search. So version 13, of course, and what that ended up in is failed inserts. Version 13 implements a retry logic for those partitions to try to retry those locks to get the insert performed, as well as do a bidirectional search to maybe search to see if a partition is available that it previously had not been available. So that should help improve our insert success rates. Index look-aside, couple improvements in version 13. We know how index look-aside works, right? We are able to look at the next successive leaf page to do our insert or delete instead of having to traverse all the way back up the index tree to find the page to do our inserts or deletes. It was used for only insert and delete operations, and only for clustering indexes and non-clustering indexes that had high cluster ratio that was based on the cat stats. It was not utilized for updates. Version 13, it can be utilized for updates now, which is good. It opens it up for more processes. And it also will benefit fast traverse block because it will help, in conjunction with that, it will help lessen get pages for all operations, inserts, updates, and deletes. And also, it can be used against non-clustering indexes when they have a high cluster ratio. And it's that's not based on the catalog statistics. So it can use a non-clustered index regardless of its cluster ratio. But of course, if it has a high cluster ratio, you'll see quite a bit of benefit from that. So fast traverse block, another feature that kind of had some issues early on with getting it to work properly. There were some limitations on it as well. And one of those was that it did not utilize non-unique indexes. You could not use that with a non-unique index in the beginning. Now, fast traverse block it really is kind of like index look-aside, but it benefits more your random processes versus your skip sequential processes versus the sequential processes that fully took advantage of index look-aside. Fast traverse block helps benefit more random or skip sequential processes for indexes. So that being said, it was not available until 508 for non-unique indexes. And that, of course, got implemented through a zparm that you could set to allow it for non-unique indexes. But it was not by default. So version 13 allows you to have this turned on by default, or it will be by default in version 13 for the non-unique indexes to be considered for FTB. And the other thing that happened in version 13 was that the key size limitation was removed. Prior to this, only columns of 64 bytes or less could take advantage of this. So now in 13, unique indexes larger than 128, unique indexes up to 128 bytes can be considered, as well as non-unique up to 128 bytes. And that includes the include column. Non-unique indexes, like I said, will automatically be considered for FTB as long as they meet the other criteria, such as the max on the key links. Now, FTB, as I was mentioning, had its share of challenges, and FTB was on by default and enabled at the subsystem level and controlled through Db2 automation. And since then, it's gone through some changes through an APAR in Db2 12, where we can control which indexes are going to utilize or are going to be considered for FTB. And this is done through a new zparm, actually, done through our install panels, where we can set up this in-memory control, and for selected indexes, we can turn that on, and then we can control it through the sysindex control table in the catalog, where we can tell Db2 which tables to consider, which indexes to consider for FTB, and so forth. So we can say, let's say I have a better example. Here we go. We can, by its action, we can say to force FTB creation, disable it, or let it remain automatic and controlled by Db2. Now here again, there's a lot of APARs that came out. You want to make sure you're current on maintenance when you're using FTB or going to attempt to use it. And through this control mechanism, it's recommended that you do this for selected indexes and test them and test their usage of FTB. And there are some new statistics that came out regarding this in May of 21, okay, another APAR. And this provides some new statistics on the usage of FTB. Okay, so you'll get a new, through our display stats command, you can see a new index traverse count option. And that will give you the following result below that allows you to see the usage numbers for the index for FTB. Online load replace. This is kind of a utility enhancement. It's one of the IBM utilities, but it's an enhancement that we can utilize versus some of the other table designs we've been utilizing over the years. When we're wanting to load a table while having the table available, right? We sometimes mirror these tables and do some application switching mechanisms while we're loading one table and reading it, the older one at the same time. Many of you probably said, well, I've done that through clone tables, right? That's another option that we can do, is do this through clone tables. However, those have restrictions too, and they can come along with outages when you're going through that switch process. So another option, a better option, is now you can do an online load replace, okay? Because those two options I just mentioned were essentially online load replaces options. And so through this implementation of share level reference, load replace share level reference in the load, we can essentially do an online load replace. So provides concurrent read access to the target table while we're building the other table or loading the shadow table sets, and then we do the switch. Okay, so that's a cool option, version 12 with an APAR, and actually it looks like it's also retroed back to version 11 if you're still hanging around there. Oh, by the way, version 11 now is out of support, so if you haven't moved on, it's time. Another feature in function level 505 was kind of a minor one, but temporal tables and archive-enabled tables were not able to be referenced in a when clause of a trigger. Okay, so they were not available for our triggers, and that kind of limited their use in some situations. So now in 505, we can have a trigger that has a when clause that references a system temporal or archive-enabled table. Okay, so when either one of these is used, when Db2 queries against those types of tables, it does a union all kind of behind the scenes to choose whether it's going to the current or the historical tables or the archive tables. And so that will be supported in the when clause, and the Db2 chooses the section of the when clause then that qualifies for the data in which table it actually resides in. Real-time statistics. This is a minor enhancement, but it's one that's just there because we need to support more workloads, right? We have more inserts happening. We have more updates happening because we have more transactions happening. So the catalog's been changed to support big int numbers for something like reorg inserts. So it can capture these large volumes by having this data type for something like reorg insert counts to support, but be supported by a big int data type. Lob compression, of course, came out in version 12, and it works against a lot of our larger objects, like text documents, XML documents, so forth. It got some improvements in version 13 with the Z15. Okay, so we got a lot. We're getting better compression ratios now for those objects that we love, right? The text objects, PDFs, JPEGs. So they're better suited now to take advantage of lob compression because the new technology that came with the Z15, with the integrated accelerator. Transparent data encryption, of course, came out in version 12 and in 502. And we got the ability to define this through the key labels. We can create the key labels directly on our Db2 tables. Okay, so we've been able to do that to have our data encrypted at the Db2 table level. And there are two new functions that came out in 505, okay, that allow us to specify the ability to encrypt our data on an update. So here's an example of updating our updating our column, protected SSN in this case. We can use the encrypt data built-in function, provided a key label and an encryption algorithm to encrypt our data. Okay, and there's also a corresponding decrypt data key function again, that came out in 505. Huffman algorithm. Okay, this came out in function level 509, and it allows us to have the Huffman algorithm supported in addition to our fixed length compression that we have been supporting, since since forever. The fixed length compression that Db2 uses is really basically kind of a Lempel-Ziv algorithm, if you will, type of compression, versus this Huffman compression is based upon some hardware compression with the Z14 compression coprocessor. And now we can specify which type we'd like to use. Okay, so we have a new subsystem parameter that controls whether or not it can be used. We also have the ability to turn this on at the object level. Okay, so we can say compress yes Huffman or fixed length. You can see the status in the catalog and table part or table space. This table space. It will show up in DSN1 comp, the comparison, if you're trying to decide which algorithm you would like to use. Keep in mind when it comes to performance, it's not always a guarantee that Huffman compression will outperform the fixed length, because one thing Huffman does not support is partial compression, decompression, which fixed length does. And that's a benefit that we got a couple releases ago that helps benefit our query performance. So depending on the compression ratio, and depending on the usage of the data, if it's random or sequential and so forth, your mileage may vary on which performance or which compression will give you the best query performance. So that's something that needs to be tested on a query by query basis, to be honest with you. Here's a look at DSN1 comp. So you could run this DSN1 comp to see if you get better compression ratios with Huffman versus fixed, so forth. So you could say comp type all on DSN1 comp, and it will give you the percentage of savings. Improved index page split information. Index page splits are hard to deal with. Okay, if you get an index page split, it means that your index, you were trying to do an update or an insert, and your index page didn't have room enough for this insert to go into, or this update that resulted in a length change to go into, and you split your page. Well, that can start to become a problem, especially when Db2 is doing maybe a 50-50 split, and he doesn't have a page to split into. And then he starts going into exhaustive searches, and leads to performance problems. Okay, so if your inserts start taking longer, you need to start looking into the fact that you might be page splitting. They're hard to find, and it's hard to tell really when it happens. But IFKID 359 that came out a couple of releases ago, I believe it was 11, does contain information about page splits if we have it turned on. And it contains who split, when the split occurred, the page number it occurred on, and so forth. So that was a nice feature to have to give us some details about the splitting. If we had those traces, if we had statistics trace class 3 on and performance trace class 3. So, but in some cases, it did not capture in what they consider a abnormal split process, where the total time is greater than 1 second. So sometimes this was not captured. And so in version 13, automatically when you go into version 13, your RTS stats will start collecting 3 new stats regarding the total number of splits, since the last reorg, split times, the elapsed time, accumulated elapsed time for splits, and the abnormal execution splits. So there's more statistics that are going to be gathered, just like normal statistics are gathered with RTS, like number of reorg or number of inserts since the last reorg. So these index split stats will be gathered in the same manner. as they were for everything else. Deletion of old stats. This can happen when you're using profile tables, profiles in run stats. So if you're using the profiles in run stats, you can choose to have run stats delete all your old statistics so you don't have inconsistent statistics lying around. Okay, so this is an option that came out in version 12 and 507. So you can clean up some of those old frequency, cardinality statistics, things that have gotten inconsistent. So with our applications now, some of the really nice features that came out in function level 505. The biggest one being the phased-in rebind. And this allows us to create copies of our packages, and then everyone who's using that package can keep using it while we're doing our rebinds, and then we'll have our new copy available once we complete our rebind, okay, without disruption. Then, so everyone can still keep using the existing one, we can do our rebind, and then the new one will be available. This, of course, you have to be using Plan Management Extended and AP Reuse Source of the option Current. Okay, so the Db2 will allow you to switch to your new package when the rebind has finished. So it allows recovery without regression recovery without incurring an application outage. Issues with the rebind. There was an issue early on that the rebind was requesting to get a conditional share intent exclusive lock on the package, which is incompatible with transactions that are needing an S lock on that particular package. So in 505, in this particular APAR, that restriction has been removed. So it removes the conditional share intent exclusive lock, and so giving us better concurrency with these phased-in rebinds. There also was a storage issue with the phase-in rebinds because it kept all the phased-out copies. And so that, of course, leads to storage problems. We're not freeing up space like we should. And also there was a storage issue with data sharing where it was keeping control blocks in ECSA, not freeing them. So in 505, some of that storage was modified so that it was better utilized. And with this following APAR in version 12, then we also have a new option to free those phased out packages. So we can clean them up out of the catalog and directory and access path repository. Okay, so you have a new free package, plan management scope, phase out. And we get rid of those old phased out copies. Profile table enhancements. If you're using profile tables, these are tables that we're using to control threads, connections, plans, packages, and so forth. And it was only available for remote applications. Version 13 is going to make profile table usage available for local applications. So opening up more usage for profile tables. And one thing that you can now control through the profile table is the release option on our packages. Okay, we all know the challenges of using release deallocate, that when we're wanting to get some DDL ran, if we're running release deallocate, we need to find a way to switch it to release commit so that we get our DDL executed. Okay, so that's always been a challenge. And with this ability to control it through the profile tables, in the profile table, there's going to be a new release package keyword, and it's going to allow us to be able to force Db2 through the attribute table. It's going to allow us to force Db2 to switch between deallocate and commit when the profile starts. Okay, so we'll have control over the release, commit, and deallocate through control tables. Again, that's if we're using control tables for system monitoring and so forth. Application granularity. So for locks, number of locks per user, number of locks per table space, Hello. This Okay, this is part 2 of the Db2 12 and 13 presentation. I got cut off. I apologize. So, picking back up where we left off, talking about application granularity for locks. So by default, or by the way Db2 is designed, this is controlled through our ZPARMs, numlock US and numlock TS, where we can control the number of locks that can be held for a user or per table space before lock escalation occurs. Okay, well that's maybe not optimal for everybody in the subsystem. So now, through function level 507 for version 12, you can actually specify the number of locks per user through global variables, and that will let you set this exclusively for a particular application, and it will override what is what is defined in the ZPARM. Okay, so you can use the set command or set statement to set this global variable equal to what you'd like it to be. So in this case here, we're saying set the locks per table space to 100. So that is now basically your personal value for numlock TS for that application. Okay, so that can be done now through global variables. Application level timeout control. This is interesting. All our timeouts are set by a ZPARM. Okay, the amount of time that our application will wait for a lock before it times out. And that's set through the IRLM wait timeout. And that's been around forever. And the default's always been 60 seconds if you're not changing that. Now, that of course, has to be changed through a bounce of Db2, and that's not always a good thing if we need to change that. And we want to change that. We want to change that. We don't want applications waiting 60 seconds for a lock. That's just bad business. But now we can change it at the application level, which is much easier to change. And it will, of course, override what is set in the IRLM ZPARM. Okay, so we have a new subsystem parameter that actually sets the default. And we can also set this through the through this special register. We could say set current lock timeout equal to whatever we'd like to set it at. Okay, so we can set it in this case, we can say set the current lock timeout to 30, so 30 seconds instead of 60. Deadlock priority. Okay, as you know, when you have a deadlock, somebody's going to get the short end of the stick. Okay, somebody's going to be the victim, and their request is going to be denied, and they're going to be rolled back. Oftentimes, that's our batch jobs that this happens to. They end up being the victim of a deadlock, which is not good. Retry logic. I don't know who does retry logic anymore. Restart or retry logic, it seems to be a dying breed that do that type of logic anymore to retry for a deadlock. It's still recommended, but even if you can get it in there, it's always not a guarantee that it's going to work optimally. So there's an option now in 501, version 13, to control the deadlock resolution priority. It is a built-in global variable, and it can be set dynamically through the set command. So in this case here, we can set it to 100, and the higher the value, the less likely your lock request will be the victim. Okay, so you hope to set it to a high priority and that you will not be the victim of a deadlock. Lock avoidance in a singleton select. That came out in an APAR just last year. And this allows us to get lock avoidance on a singleton select, okay, in the event that singleton select was defined isolation level, cursor stability, and current data yes. Okay, in that case, it would not have been able to get lock avoidance for a singleton select, but this APAR allows that to happen. And this actually is set with a default provided by that new ZPARM. Greater number of concurrent threads. This is saying goes hand in hand with we're talking about the ability to have more open data sets. Because we have that storage relief now in version 13, and you can also have more concurrent threads supported, because also the storage for your threads has been moved above the bar. Okay, so that allows us to have more room so we can have more concurrent users. They've also improved the interface between DBM1 and the distributed address spaces. Okay, some of those control blocks are now above the bar, so better operation and performance for our operations, across memory operations between DBM1 and the distributed address space. Row sort length, well, that was actually a version 12 feature that allowed us to help reduce our sort length. Db2 did not need the column for the sort. It actually removed it from the sort work file. Now that goes along the lines of another improvement with sorts and dealing with the fact that we sometimes put the wrong data or too much data into our sorts, not thinking about the performance implications. The more columns you include in a sort, the larger your sort record's going to be, and that's going to affect your sort performance in the end. With a varchar column, that's particularly true, because a varchar column, while the varchar may be defined as 200, if you're only using 10 bytes, it doesn't matter to a sort. If the varchar is defined to be in the sort, it will pad to the full length. So this feature will allow the varchar to be a little bit smarter. While it sees that you've got this varchar in the sort, it will determine the actual amount of data in there, and during the first execution of the query, it will only allocate that maximum length that's been used in the sort. Okay, and then for subsequent executions, it will use that value that it determined. Okay, so hopefully it reduces the amount of sort storage that you need and sort work file buffer pool storage space that you need. List prefetch for merge. If you're using merge, you'll probably notice that you've never been able to get a list prefetch access path. Okay, so index access can now be used with a merge statement. Okay, and if the potential is there, you'll see that as in your plan table, of course. ListAg is a function that came out in 5.01, and it provides a new built-in function, Db2, which is kind of neat. Okay, so we have this ListAg function, and showing an example. Okay, so this is this example here is going to define a list of employees by department. Okay, so in the past we would have had to define a cursor from the table, fetch the data, use application logic to evaluate the department that they're in, and then perform the concatenation to get this list of employees by department. And that could be a little bit of an expensive process. But with this ListAg, as you can see, we can use this function, and we could say I want all my employees, and then I want to concatenate it with I want to list the employees horizontally, if you will, with the semicolon concatenation, and then I want them by department, and I want them listed horizontally. As you can see, we're grouping it by department, so all the employees in Department 20 are then going to be listed out in the employee name list that we've built. And compared to how you would do that in the past, it's quite a significant reduction, because you're not running a lot of application code to do this type of listing. And with version 13, you got support for substring for the ListAg function. And what that does is it allows you better sort performance, because if this ListAg is requiring a sort, Db2 will only use the substring value instead of the entire value of the ListAg string result. Hashing functions came out in 5.01, built into Db2, and the hashing functions are kind of cool. It allows you to use a CRC hash, cyclical redundancy check, or an MD5 hash to allow you to create a hash value for your data. And this is a nice feature to use. We've used it in the past where we've had to do comparisons to see if our data's changed by hashing entire rows, their values, and then we compare incoming data to those hashed values, and we can see whether or not the data has changed without having to go through and do an update to find that information out. It's much more efficient and it works very well. So now you can use this hash function because it's built into Db2. Creating, replacing stored procedures, got an enhancement in 507 that we can say replace stored procedures, native or external. Okay, so you're wanting to make some changes. Instead of having to drop and recreate these procedures, you can now issue a replace on them. SQL Data Insights, I saved this one for the final here because this is a big option. It's an option in version 13, and it's for those that are wanting to get into the area of artificial intelligence. There's support for this now in the Db2 model, or I'm sorry, in the Db2 engine. Okay, so it will provide us insight into our relational database for better business decisions. There's no need for the ETL process to move the data off to some other platform to do this. And there's no need within this product, within this tool, if you will, to build these machine learning models and have to have the expertise of a data scientist to do it. So there's some built-in functions now that came along with this to help perform these operations. And this, again, is an optional feature. You install a GUI tool and you identify tables to the tool, and then you build the AI queries utilizing these built-in functions and so forth. And of course, and then it runs in the Db2 engine. But there's a lot more to this. There's a lot of documentation and a lot of presentations on it as well out there. So in summary, just to give you an idea of what's come out since version 12 came out in 2016 and what version 13 is bringing to the table in terms of our database, our application, and around the performance and scalability, and what are some of these options we can use and exploit. Okay, so I hope you enjoyed that, and please provide your feedback to the GSC. Thank you very much.
Well, thank you everyone for joining. If you have any questions, then please send them to either me or Colin, and we would forward them to Susan herself. We hope you enjoyed that session, and we look forward to seeing you again this afternoon after our lunch break. So see you again at 2 p.m.